Good afternoon, guys. I'm so happy to give this speech at sub0. And actually, I just missed my slot in the morning, so I was rescheduled to this one. So many thanks to the crews and all of you. And today, my topic gonna be introducing blob transaction and data availability problem. And I will give you a very general introduction on the basics and the fundamentals, and discuss about how we can bring this data availability solution to the Polkadot ecosystem. Okay, so I'm Mexy from Crust Network. I'm the product lead of the Crust Network. So before we dive into this topic, let me briefly introduce Crust Network, about who we are, what we did, and what we have contributed in the Polkadot ecosystem. Crust Network is basically a parachain that is made specifically for decentralized storage. It supports IPFS native storage, so you can just take Crust Network as a incentive layer built upon IPFS. And we have been run over mainnet for more than 2 years, with its on its peak have 600 petabytes, more than 1,500 nodes, that being storage providers, and like more than 2 million storage orders on chain, and it's still increasing. And also, we are among one of the very early Polkadot contributors and the substrate contributors. Like we have Web3 grant, Web3 group camp, and we are a member of Substrate Builder program. So on the application side, we provide many different solutions and products for diverse scenarios for decentralized storage, such as being a Web3 decentralized storage infrastructure that can be integrated by other blockchains. So users can just contract and place storage orders on chain. And also, we can be a very good solution for decentralized hosting and decentralized storage, especially for those static data, like the front end of a DeFi application, and the metadata of NFTs and DIDs and social files, etc. And also, we have provide for our business users and personal users with user interface applications, which is Crust clouds for to be users, and Crust files, just like a personal disk based on on-chain storage and IPFS for personal users. Okay, so we can get to study with this topic, the data availability. So let me give you a very simple example on what is data availability and why it is important. Imagine you are running a light node, for example, for Bitcoin or Ethereum. And if you want to verify a transaction, for example, just a simple payment transaction, and you can require the data from nearby full nodes for this certain transaction, and you can put this transaction in the Merkle tree of a certain block, and you can verify the transaction is in the block, and the block is valid, and the transaction is valid. So this example is a very good example for data availability, because if you are the owner of this light node, that you know you can access the data and you can verify the data. It is valid. And you know that you can do that. So it gives you something like a confidence or assurance that you can always access to the data and have it verified in a trustless way. So the most interesting thing about this definition is that confidence is something like a very, it's a feeling, it's not a fact. You feel you are secured and safe, that you can verify the transaction, and that is powerful. And also, this confidence is how optimism rollups in Ethereum, like Arbitrum and Optimism, works, because you have confidence on the data availability, and you don't really need to verify every transaction for the rollups. So basically, this is the very basic concepts about data availability. And here is a story of why we are here now. From the very beginning, when people are talking about the scaling problem of Ethereum, I think it's like 5 or 6 years ago, and people are talking about a solution called sharding. But that sharding is very different from the dank sharding today. The original sharding is kind of splitting the whole Ethereum network into several subnets. And these subnets can run parallel for execution. So it's actually an execution sharding. But it turned out the result is the market has accepted or welcomed another very different pathway called rollups. And today, Ethereum has established a so-called rollup-centric roadmap in the future. But here's a new problem. If you look at all the layer 2s today running on Ethereum, the data cost can account for like more than 90% of all the rollup costs for these layer 2s. So Ethereum community know that, okay, it's time to get a new kind of sharding. We call that data sharding because we have rollups, so we don't need to shard execution. But we need to shard data because it's overload on the Ethereum layer 1 blockchain. So here we have, we call that proto-dank sharding in the coming future, and we have further full dank sharding and data availability sampling. I think it will be followed later after the proto-dank sharding. And in case you don't, if you're not very familiar with this dank sharding thing, I have a very simple explanation. Just 3 steps how this dank sharding will be implemented in the future. So the first step gonna be introducing a special transaction type called Blob transaction, or we call that a data transaction. And in this transaction, users can attach a data blob, which acts like a data space for transaction data and generic data. And the data put in this data blob, it acts like a sidecar attachment to the data transaction. And the full nodes or validators will only keep this blob and verify this block for about like 1 or 2 weeks. And they will discard this blob. So, which means validators will not forever or permanently maintain this data blob. So the introduction of blob actually save a lot of resources on chain for validators and full nodes because they don't need to maintain these blobs forever. So this is the first step, and this step will be implemented in the coming proto-dank sharding. And the second step is Ethereum introduced a committee for data availability. This committee basically works like we can randomly select a small group of validators. And we have these validators in charge of processing and verifying blob transaction and the the data in the blob. And it is compatible with the on-chain data transaction. So this will further save storage resources on-chain because there's always only a small group of, or a portion of the full nodes or validators working on this data, availability thing. They are in charge of the data publishment on-chain. And further, we will have DAS, which is short for data availability sampling. In the DAS design, we will introduce we are called the IS encoding and decoding scheme, which will extend the original data transaction data 4 times, and we split the whole data into many chunks, many shards. And for a full node or validator, he only need to store, receive, store, and verify several shards and provide a shard commitment to the validator network. And based on these shards that are distributed on a huge network of validators on Ethereum, we can always recover the original data for the blob. So DES, it further released the resources of full nodes or validators because only a small portion of validators is in charge of processing this blob transaction, and only a small portion of the data blob will be processed by these committees of data availability. So let me give you some key points, okay, personally, key points about how we look into this data problem and where we are now. The first one is we are seeing a trend of all the layer 1 blockchains evolving from a monolith to a modular design. The reason for this, I think, is because, for example, in Ethereum, we are already facing the bottleneck for its scalability. So the data cost or the whole cost for the processing a transaction on chain gonna be very expensive. It's like when I'm doing a Uniswap swap transaction on Ethereum today, it's gonna cost like $30 or $40 or even more. That is exactly because we have a bottleneck on the performance of Ethereum scalability, that is the data cost. So if you take a look at the proto-dank sharding and the full dank sharding solution, you may find out that Ethereum is actually trying to separate all of its data availability or data publishment function or functionalities out of its original beacon chains and validator sets. So this indicates that if we can separate all the functionalities of DA out of its original ones, we can also separate these functions into a standalone blockchain. So this is why we have the so-called alternative DA like Celestia. It works because these functionalities can be separated and you put it in a standalone blockchain and the data cost will be reduced dramatically. It's like 99% to the original ones. And the second question gonna be a little controversial between within the community because people are talking about, okay, I know Ethereum is implementing old DA. They have a DA layer, they have this concept, and because they have rollups and layer 2s, they need a cheaper DA to reduce the total cost of rollups. But is it also applicable for Polkadot or other blockchains? I'm not gonna talk very much detail about that, but my general answer to this question is yes, we need a DA layer, even for Polkadot, even for other layer one blockchains, which is not natively designed to adapt the DA layer. The reason is because modularity is a very strong demand from the market, and if we accept the modularity design, we always find that there will be some points to be a bottleneck for the total cost reduction. And data cost always be the of the important ones, or it always prevails, or it always stand out, just like in Ethereum, because the blockchain today are getting more and more bulky, and they are just overloaded with a lot of historic on-chain data, and this data don't need to be stored permanently on-chain. So this is why I think there's a demand from the market that every layer one blockchain is exploring some sort of DA solution, and they're talking about it, so they become a very heated discussion. within these communities. And this is a sub-DA proposal, which is proposed by Crust network. This looks a little bit complicated, but don't worry, I will explain this proposal, explain this solution from two different perspectives. The first perspective gonna be like, we plan to provide a DA package for substrate, which is marked in purple, a DA package. And we will support user blob transaction, which is just as the same design and architecture like the Ethereum ones. So users can have a standard interface operating with the DA layer for the substrate-based blockchains. And a DAS based on peer DAS will be implemented in the future to support a decentralized data availability implementation, because DAS is naturally decentralized solution. And I specifically mentioned this sidecar design because if you take from another perspective, you may find that this sidecar design of the data blob is a very good implementation of on-chain data storage. Because for the DA scenario or for the data publishment scenario, we only keep the data on-chain for like 2 months. But if you ask a node from the auto DA parachain to store this data for like 1 year or 2 years or even more, you are actually doing a decentralized storage, just like what Crust network is always doing in the past 2 years. So we think this sidecar design of the blob transaction can be a very good standardized formation and implementation for the data carrier for on-chain decentralized storage. And also we have blob verified palette, which is pretty much vanilla, the same like blob verification design in the Ethereum ecosystem. And another perspective is we have a parachain called the sub-DA, which is substrate-based standalone parachain, which offers DA services to all the substrate-based parachains in the ecosystem of Polkadot. And for this parachain, we're gonna have a staking collector, which allow all Polkadot users to restake their VDOT to provide a shared security to all the nodes that performs the DAS, the data collecting, storing, and the verification, and shared commitment things. And a standalone block market will be supported, so we can have separated pricing for all the DA blobs, which will substantially decrease or reduce the data cost for processing DA transaction and the blob transaction on chain. And also we have sub-DA assurance pool, which is matched design of this sidecar, where users are allowed to put storage fee into this assurance pool. If you put like less money for data publishment, and the data will be maintained for like 2 months or 1 month. But if you put more money, you can have your data guaranteed to be stored on chain and always be retrievable from the DAS retrieval and decoding scheme. And also we have, of course, we have XCM interface for interoperation between within the ecosystem of substrate-based blockchains. So this is gonna be the an overview of our architecture for this sub-DA. I guess this gonna be the for today's topic. And if you are interested in this DA topic and the sub-DA design, you can always find me on this. We have a Telegram account, my personal one, and we can talk about this after the meeting, after the party. So thank you very much for today's topic.
Anyone have any question? We have like 4 more minutes. Have a question for? All right. I think we don't have. Oh yeah, here you go.
So what do you use inside? Is it like a KZG scheme similar to Avail or Ethereum, or using like Merkle tree commitments as in Celestia when this data availability sampling is performed? Yeah.
I think it will be a KZG commitment you just mentioned. Yeah.
Okay, so it's also a 2D scheme or 1.5D. Like you extend columns and rows.
Like yeah, 2D.
Right? Okay. Right.
Two-dimensional. Yeah.
Okay.
All right, in the back.
I have discussed with a couple of founders back to the Bay Area. They're talking about the maximum storage capability of each blob of the dank sharding. So they set up to 4 megabytes. That's what they are trying to achieve. So 256 kilobytes per piece, and they multiply it by 16. So 16 segments.
Yes, like 4 to 32 megabytes per block.
That's that's theoretically. So actually, what they can achieve is like 4 megabytes. So I'm wondering how on Crust Network how you guys achieve or think about the maximum versus the practical.
I think there's a balance to strike because. Theoretically, there are 3 factors that will affect the performance and the decentralization level and the security level of this data availability sampling network. The first factor is how many shards you will split these full data chunks. Like you split it into 1,000 data shards. And the second factor is the size of these blobs. And if you want this blob to be very huge, then you need to have more data shards to spread the data shards in the network. And as a consequence, you will need more clients or nodes processing these data shards. And I have read an article on this, and there is analysis of these 3 factors and how they change will affect the whole balance. I cannot recall the detailed number, but the general conclusion is that for a feasible design for this DES network, the clients or the nodes number gonna be like between 100 and 500, because it cannot be like too fewer than 100, and more than 1,000 is also not very, not very possible, because you cannot always guarantee that there will be more than 1,000 nodes. And to match these nodes numbers, we have data shards for like it's about the 500 level, no more than 2,000, because if you have too many data shards, then you will have the clients to process and to store more data shards, and there is a higher possibility that they lose these data shards, and they need to generate a commitment for the shard they have for like periodically, so which will increase their burden. So
my understanding is that there will be a balance between the redundancy.
Yeah, these 3 factors. Yeah.
Yeah, I mean, feel free to drop me the article if you still have that in hand. Yeah. Thanks.
All right.
Because awesome. This is not a final solution, not a final one. So we are exploring this. So what balance is the best to strike?
Yeah, looking forward to the result.